because I already told you that the methods, RK method is not a single method. They are the family of methods. Like there exist many variants of this method. So there are two order, there are third order, there are five order, and there are some other order as well. So okay, so you have to point out clearly which order you are referring in your work. So this is RK method order 4 we are going to use in our calculation. So same thing, nothing has been changed. Like you have to solve same problem, w dava t ut right hand function f of ut with the condition u at time 0 is 20 degrees centigrade given to you, and we are using n equal to 2 intervals. This is by our choice. We choose some, you can choose 4, 5, 10, but keep in mind you have to compute accordingly. If it is not given to you, it's up to your choice. Okay, n equal to 2, and what else given to us? And yes, and we need solution at 10 seconds. So I just summarize the whole problem again so that I do not need to go back again. So let's start the process of solution using RK method of the stage 4, the same problem. So just for your understanding, in a time scale, if T naught is 0, so temperature is given to you 20 degrees centigrade, and the evolution of the temperature is governed by the following differential equation. It is arbitrary. Okay, so and we want to use two intervals. This means one interval and two intervals. So from T naught, I will not go to the end point. I will go some intermediate point T1, 5 seconds, and from T1 I will move to another point T2, which is 10 seconds. This is, there is no need to calculate. We can compute directly. T naught H add करते जाएंगे, so we will find H is 5 from same problem. And what else? From here, first we have to find U1. Once we know U1, that is we know U1 and T1, then we will use T1 and T2. We will find the U2. So these two are unknown for the time being. So step by step. But what happened in RK4, when I use this data, that is I0, I will try to use this data to predict the solution at there. But I will not do it in one step or in a two step, just like color modified respectively. I have to perform 4 calculations in between to reach there. Okay. So that will increase my calculations as well, but the accuracy also increase. But here we are not comparing with the exact answer, so we are just relying on the theory. It says that this method is much accurate as compared to the orders and modified orders. So let's implement that part. Okay, how to implement that part? We will do it like that. Dava u dava t is ut. So for I equal to 0. So for I equal to 0, you remember the solution will be u1 not y. U1 is equal to u naught plus k1. K1 are not index, they always called k1, k2, k2 for every step. 2 times of k2, 2 times of k3 plus k4 divided by 6. They are the weighted average. So u naught we know this is 20 degrees centigrade, and but we don't know k1, k2. We have to find, and this solution belongs to t1 equal to 5 seconds. But to compute that solution, we need K1, K2, K3, K4 first. So we have to compute K1, K2, K3, and then I will plug all these values here and simplify it so that I will get U1, which is the solution at 5 seconds. So I have to perform 4 calculations. So in RK method, you will have to perform more calculations, but the answer that you will get is much stable and much accurate. The theme was so far is that these are step-by-step methods. You cannot go in a one jump. Smaller the step, you will get much better accuracy. This is the one way. The other way is that, okay, if you have a certain steps, then you can do one thing. You can switch to a different method like 4 stage or 5 stage RK method. What you have to do there, in that step, you have to compute intermediate steps. So these are K1, K2 are intermediate calculations, so that you will reach to the final solution, next step solution. So let's define it like that. We all know K1 is defined like H in terms of F not U not. Okay, and we know that H is 5 and F. I'm discussing the same problem, so this is your F ut. So which means that I have to put T naught U naught. So 5 T naught is 0 and U naught is 20. So in fact K1 is comes to 0. But that's not enough. This is the only one part I have computed. I need K2 as well. But I cannot compute K2 directly. I need K1 first. So why? I will write down in the next slide. I need a space, so I'm partitioning the board. Okay, so K2 is equal to H. You have to memorize this thing straight. Okay, F at what position we have to evaluate? We have to evaluate T naught plus H by 2, comma. This is half of that interval. Okay, Q naught plus K1 by 2. Keep in mind this thing K1. We have computed on a previous slide. Also it is 0, but you have to compute K1 first to get K naught. So let me replace the values. H is 5, F T naught is 0. Let me write down. H is 5, so it is 5 by 2. This is the first time, so we are doing it accordingly. U naught is 20, and the accidentally K1 is 0. You can recall it. K1 is 0. Okay, not always. This is happening. This usually happen when you have an initial condition t equal to 0 or x equal to 0. This happens usually. It's not necessary for other problems as well. So let me complete this thing. K2 5 function needs to be read at 5 by 2 is 2.5 20. Okay, so this is your t, this is your u. So the final answer would be 5 ut 2.5 t into 20. So you will get this is your k2. k2 का आंसर आ जाएगा. What would be the answer of k2? Let me calculate directly. 5.2.5 into 20. So that would be comes to us 250. Okay, similarly I need to compute. I'm still in the same step. Okay, I have not computed a solution at t equal to 5, still in the same step. But to process that step I need k1 k2 k3. Now I'm going to compute k3. K3 is h f of t naught plus h by 2 still, comma. This, remember this, in k2 k3 x coordinate as the t independent remains the same. Okay, but this will be changed. This is equal to u naught plus k2 by 2. Remember this k2 will be used here. So this is 5 f. We know that after simplification we just did that. This will be equal to 2.5, and to that part u naught is 20. K2 is just computed as 250 divided by 2. So K3, this implies K3 equal to 5 into function needs to be read at 2.5, comma, that would be 125, and 125 plus 20, 145, I guess. It's 145. Okay, this will be 125, and 125 plus 20, 145. So I need to read this function, whatever the function is on this. So it is equal to u times of t. This is t, and this is u, 145. Okay, so when you solve it, you will get 5 into 2.5 into 145. Okay, so the answer would be 1812.5. It is not the final answer, it is just a K3. Now you need K4. For K4, little bit slight different formulation. Use H T naught plus H. Okay, there is no H by 2. And similarly, U naught plus K3. There is no K3 by 2. Okay, keep in mind this. So this is equal to 5. F T naught is 0, 0 plus H. 0 plus H is 5. 0 plus H is 5, so 0 plus 5 is 5. Comma U naught is 20. And P3 is just computed above 181.2.5. So P4 will be 5 times of function needs to be read at 5 comma, and that would be equal to 132 plus 20. So that would be equal to 1832.5. Okay, so I need to read the function on this one. So 5 times just like that. The function is very easy, t times of u. So t is 5 and u is 1832.5. So multiply by 25. So I will get something around 45,812 times. We have selected a random problem, so it's giving so huge numbers. Seems like it is a real completion problem, but like that. Okay. So I have K1, K2, K3. Still, student, keep in mind that I am still I0. That is T naught 0, U naught 20. I'm still at that stage. I'm still at that stage, but I have computed all the data that will make me to shift from this state to that state. So now I have K1, K2, K3, K4. I have to put all of them here, divide by 6 and add up into a U naught. So that I will get U1, which belongs to a 5 second. Okay. So let's see. This implies what? This implies so we need U1. U1 is U naught. U naught is 20 plus H. No, I don't think so. There is any H. Okay. So it is K1. So what is K1? K1 is 0. What is K2? K2 is 250. That would be 0 plus 2 times of 250 plus 2 times of 1812.5 plus K4. K4 is 45812.5. 45812.5. Okay, divided by 6. Weighted average. So this will be U1 after whole simplification. Let me simplify for this. So this is 45812.5 plus 2 into 1812.5 plus 2 into 250 plus, okay. So this is the amount divided by 6. So we are getting this plus 20. So we are getting this answer 8342.91 at t1 equal to 5 seconds. So this is the answer based on RK method, which is much accurate answer comparative to the theoretical studies. But here is no exact answer is given, so we are not comparing. But this is the answer at 5. We do not need a solution at 5. So remember what I was saying earlier. To move from one step to another step, you need to perform more calculations. So when you have to perform more calculations, you get much accuracy. So I still at one stage, but this is the amount of the calculation I need to do there. Okay, so keep in mind this is one of the issues that we are dealing with, but this is not the final answer. Now I have to do what I have to do. I will leave it for you guys to complete this problem. So for I equal to 1, so I equal to 1, I have, which means that what data I have to use, I have to use t1 equal to 5 seconds and u1 equal to 8342.91 centigrade. So the data will be like this. So for this interval, this stage, the Euler scheme will be u2 is equal to u1. Note now, I have to use u1. It purely depends on the previous state. Like I want to move to u2, then I need information from u1. u1 k1 2 times of k2 plus 2 times of k3 k4 divided by 6. Instead, one thing I want to share based on the experience of teaching and previous students feedback on this problem. Sometimes students thinks that they just need to compute k1, k2, k3 one time. Like they think that the k1, k2 computed here will be used also in this step. No, for each step you have to compute k1, k2, k3, k4 new. Okay, so the k1, k2 you have computed previously is only for that step. That is, you move from using this information, you want to move there, which you did. So you have computed k1, k2, k3 in between this interval. Once you are there, their previous data has nothing importance for you. Now you have this data I equal to 1, that is t1 and u1, and you want to move from this to the final time t2 to u2. So you have to compute k1, k2, k3, k4 again. Okay, so keep in mind this thing. And similarly for modified order, use tariff is not fixed. It will compute it on each step again and again. This is not fixed. Okay, because there is no index. So sometimes students think that okay, use tariff is fixed. No, it's not fixed. For every step you have within a step it is fixed, but for each step it's not the same. It will change it. Okay, so this is the point. So this is the scheme. I need to compute all these things. ये solution belong करेगा at t equal to 10 seconds, which is the final time where we want to find the solution. Where I'm just writing the what is the k1, k2 in terms of u2, u2 look like. K1 is equal to h times of f of t1 u1. Note down this thing. It is not t naught now. It is t1 u1. So obviously k1 will be changed because k1 previously computed t naught u0. It is not t naught u0 anymore. So it's t1 u1. These values. Obviously k1 is changed. So k1, k2, k3, k4 needs to be computed in each step. Okay. So once you compute all this thing, then you have to compute k2. K2 will be equal to h times of f of t1 plus h by 2. Okay. And u1 plus k1 by 2. Similarly, k3 is equal to h times of f t1 plus h by 2 comma u1 plus k2 by 2. And similarly, I will writing the third one at there just to complete the topic. I'm letting you to complete this data set. K4 is equal to h times of f evaluated at t1 plus h. Keep in mind in last there is no h by 2. And similarly, u1 plus k4, k3 sorry. So you once you compute all k1, k2, k3 and k4 based on this formula, you have to put all of them there in this fashion 2 times k2, k3 plus k1, k4 divided by 6 and add them in the previous solution. So you will get a solution at the final time. Okay, this is how the process works. So Euler for a given time step is less accurate as compared to the modified, and modified and Eulers are comparatively less accurate as compared to the RK method of order 4 for a given h. Okay, if the interval is fixed, problem is fixed, and then you want to compare all these three methods, so you will find that RK method gives you the best result. But the problem is that if you want to enhance the accuracy, then you have to perform more calculations. That's the bottleneck. Okay, so RK method is better, but computationally involved. You have to compute more calculations. Euler method is more simplest, one step, one calculation each step, but it's less accurate. You can make it accurate when you have to use very small h, which means you have to increase number of points, which means you have to perform so many calculations so that you can reach to the end point. So that's why to optimize the calculation, what we do, we focus on the method that can permit us to use larger edge, but keeping the accuracy reasonable. So that's why we usually prefer to solve RK method, differential equation of this type using RK method, because RK method, here we have learning this process, so we have to do it manually, but in real time we do not do manually. There is a computer course that can perform for you. If you go to the MATLAB or other, you can see that RK4 or RK methods are built in inside your MATLAB library. What they need, they just need you the following information: what is the right hand side function, from where you want to start, what is the initial condition, and at what time you want to compute the solution. So they will do it for you. Okay, so they are built in. So when in general, when you have to solve the differential equations like that, so go for RK method and try to solve using computers while keeping edge as much as small you can do it. Okay. So MATLAB has these built-in features as well. So this is the main strategy that is implemented there. Okay. So that's also remarks. Practice sums you can select from the book, any book. You can just go RK method, ordinary solution of numerical solution, ordinary differential equation. You can find so many problems, because problem is nothing. The only thing you need: differential equation, you need starting condition and number of intervals, and solution to what point you want to find. That's the only thing you require. Once you know this thing, you are done. Okay. So this is my remarks for this point. Okay, student. So practice it. If you don't find any problem, good, let me know. I will share the literature with you.